Hi, here we go. We are on 8M4 lesson 24. 24 lessons out of 31, where we are learning pretty much algebra, all the meat of your 8th grade year. Really one of the most challenging times, as well as one of the most important sets of lessons you'll take going forward from here. So let's get going. Again, 8M4 lesson 24, Introduction to Simultaneous Equations. We're going to be putting together a lot of what we've learned so far in lessons 1 through 23. And I'm going to try and take you through this and try and, synthesize some of what we've learned so it all kind of hopefully makes sense to you. Let's start off and let's just kind of go over some of the key things that we've learned so far. And the first thing I want to say is that these things, algebraic equations, graphs of those algebraic equations, charts or T-charts, and then word problems, these things are all the same thing. These are all can be used to show the same relationship. Okay, they're just alternate methods of showing the same thing. So I can take an algebraic equation and I can make a graph out of it. I can take an algebraic equation and make a chart from it. I can make a word problem out of it. If I have a word problem, I can make a chart, a graph, an algebraic equation out of it. I can go between any of these four things. So let's just get rid of this little orange thing, and I'm going to show you a crystal clear example of what I am talking about. And so we're going to show this only in terms of linear equations. Okay, we're just going to use linear equations. These relationships exist in other types of equations, but we're just going to stick today to linear equations. So let's get rid of this and let's just talk about an example. So let's talk about the example of that we have this algebraic equation of y equals 60x. And we know that that means plus 0 to make an equation out of it. In this equation, to make a y equals mx plus b equation out of it. But remember, if we talk about this equation, so you can't be forgetting anything we've done so far. So in this example, we have our slope and our y-intercept. I'm just going to write over here what we started with, y equals 60x. There's our slope and our y-intercept. So we can make a graph out of this thing. And so we can start at 0, 0, because that's our y-intercept. And then we can go up 60 and over 1. This is maybe hard to read, but this is I'll just label this a little bit better so you can maybe read this. Hard to know sometimes what comes through on YouTube. And over here we have 1, 2, 3, 4, 5, 6. So we go up 1, that's 60, up 2, and that's 120. 3 is 180. Yeah, and we can make a line out of this. So let's just go ahead and make our line, and it goes through all those points. And looks great. So there's our graph, right? And this is a linear equation, right? Because we know that because there's no exponents here or here, there's none there and there's none there, which implies an exponent of 1. And we know this must be linear. And this line, this graph, confirms that it's linear because we have this slope and this y-intercept. We can make a chart out of this. And so I'm going to just really quickly create this T-chart. And we're going to make, our x and our y. And at 0, we get 0. At 1, we get 60. At 2, we have 120. At 3, we have 180. And so on and so on and so on. And these are all the same thing. This graph represents this algebraic equation, and this algebraic equation can be used to generate a t-chart. And this t-chart, all these points, all these ordered pairs, all live on this graph. So these are all the same thing. And let me make a word problem out of it for you, just to really, summarize and bring this all back to reality that math matters. So here's my word problem. My dad drove our family on a trip at a constant rate of 60 miles per hour. So after 1 hour, if we drive at a constant rate of 60 miles an hour, we start at 0, 0. This is 0 is now our time in hours, and y is our distance in miles. So this would be, this y-axis is now miles, and our x-axis is time in hours. And so remember, if we go back, our units of measure for our rate is always y over x, which is miles per hour, right? The units of our slope, and we learned this probably 3 or 4 lessons ago, are always y over x. So we can always check our neat word problem. So 60 miles per hour is our rate. And we remember that rates equal slopes. Our slope is 60, and our units are miles per hour. Everything's just so neatly tying together. So let's do one more example where we bring in this new concept of simultaneous equations. And we're going to do this on the next page. And what we need to remember is we have this thing, 60 miles per hour, y equals 60x, and this is my dad drove our family. Okay, so we're just going to come over here to page 2. You can flip back and forth in the YouTube if you need to. And over here, we're going to say y equals 60x. This is my dad drove car 60 miles per hour. And we're going to take our point of 0, 0. And remember, this is 50, 100, 200, 300, 1, 2. And you're going to get the sense of the simultaneous piece here in a second. But, and I'll explain simultaneous equations. Okay, so, and then we had 1, 60, 2, 120, 3, 180. I just draw the 3, 180. We actually end up with 4, 240. And so let's graph this thing. And so we're going to do this whole thing in orange. And so this is my dad's rate of driving our family, right? And we had a chart, and we even had a chart here with x and y, and we had 0, 0, 1, 60, and we had 3, 180, and we have more points. We have 5, 300. You can figure this out for yourself. So there's our orange graph. Now, what I want to do is I want to introduce a second graph equation on this same piece of paper. So now I want to tell a different story. So now this time we started the orange story. We started with an algebraic equation. Now I want to start with a word problem. And this word problem is my mom worked late. So she drove another car at 75 miles per hour. But started 1 hour late. So what I wanted, so this is the word problem. So this is the word problem, our word problem. And that's a verbal model. I just wrote this word here, verbal model. You may hear that from a teacher from time to time. That's just another word for a word problem, a verbal model. Okay. So now what can we do here? Let's make a little chart of what my mom did. And so over here, we're going to say, well, X and Y. Well, she didn't start until 1 hour. So at 1 hour, where was she? If she started at 1 hour, she wasn't anywhere. So she was at 0. After 2 hours, she was where? 75, because she started driving at hour 1. So relative to my dad, she was 0 at 1 hour, at 2 hours, 75. At 3 hours, she'd been driving for 2 hours, so that's 150. Just making sense? So after 4 hours, she was at 225. So let's plot this. So we'll do this one in green. My mom, so this is our chart. We haven't done our algebraic equation yet, but let's just do our graph. We're going to do we've done this one, we've done this one. We're going to do sorry, we haven't done the algebraic equation. I'll put little boxes here and we'll check them off as we do them. So we started with the word problem. Then we did a chart. Now we're going to do the graph. So after 1, she was at 0. After 2, she was at 75. After 3, she was at 150. After 4, she was at 225. Okay, so let's make a graph out of this guy. Let's graph her progress. Wow, look at that. So my question is, it looks like these lines catch up to each other. And that makes sense. All right, so we've graphed it. And it makes sense that they'll graph up, they'll run into each other. And let's look at that. Why is that true? Why is that true? It's true because my dad is driving slower. My mom's driving faster. So from a word problem perspective, let's think about it. If one person is driving a car, my dad's driving, oh, wow, that's a terrible car. Well, this is not a great car either. But my dad's driving this way, and he's going at 60 miles per hour. And my mom's back here in her car. Wow, look at that car. That's a terrible car, Mr. Lipscomb. Let's do another. Not that this is a great car either, but she's back here and she's going 75 miles per hour. So eventually she's going to catch my dad. So that makes sense. Let's look at it from the chart perspective. On the chart perspective, my dad's getting 60, only going 60 extra every single time there's an hour, right? At 2, there's 120, and there's 4, there's 240. He's only adding 60 for everyone, but my mom's adding 75 every hour. So it makes sense that she'll catch up on this chart as well. Let's see, from the graph perspective, this one, the green, is steeper. So because it's steeper, you definitely get the sense that it's going to eventually catch up to that orange one that's not as steep. So These are called simultaneous equations. And that's what we're going to be talking about for the next, probably all the way through lesson 31, through the rest of the unit. So for another 7 days. And this is just meant to give you a sense of what we're doing. So you can also go ahead and you could calculate this, this green algebraic equation and remind ourselves how we can do it. Well, we know the slope. We know the slope because we're told it's 75 miles per hour. So we know on this green thing we have, you know, y equals mx plus b, and we know that m is 75 on the green one. So we can just plug in a point here, and I'm going to choose this point to make it really easy. So let's say we put, you know, we're going to put a 1 in here and a 0 in here. And so we go y, so we go 0 equals 75 times 1 plus b. So 0 equals 75 plus b. So subtracting 75 from both sides, we get b equals minus 75. So we can make our equation be, because in m is 75, so our equation is y equals 75x minus 75. And I did that just for completeness and to remind you that we can't forget how to do these types of calculations going forward. So I know I went through that a little bit fast, but we had a whole lesson where we talked about using lines, and if we know the a point on the line, one or more points on the line, and a slope, that we can certainly find the equation of that line. Okay, notice this is, I'm going to give you a little star here, and this is going to be homework help because there is an example, there is a homework problem like this one. I'm just going to give you that you know, that double star here, and I'm also going to just put down a happy cat because we should. Okay, now the last thing we're going to do here is, well, let's just summarize what we've learned so far. Let's just summarize it real quick. So the last 8 lessons talk about simultaneous equations. We can solve them, and simultaneous equations are 2 linear equations. Okay, and they generally meet at exactly 1 point, right? Two lines generally meet in one and only 1 point. There's some exceptions, and the 2 exceptions are parallel lines. Parallel lines never meet. And then lines on top of each other meet infinite times, right? Because if a line's on top of each other, every single point on the line is a place where they meet. And so this place where they meet, this is called the solution, right? Solution to simultaneous equations. So that's the whole idea of simultaneous equation. We're not talking about one line anymore. We're talking about two. We're trying to figure out where they meet, with the possible exception that they may never meet or that they may be on top of each other. But these are rare. But we'll discuss those in in an upcoming lesson. So we can solve, which means to find solution. We can find the solution where they meet, equations, using algebra. So this is where you have 1 equals 60x and y equals 75x minus 75, which is the two algebraic equations, A, that we had from the previous example. We can solve it B using graphs. That's where we had this graph and we had this graph, and then we could find the intersection here. Solution, we'll call it the solution. Or C, we can solve it using charts or T-charts. Okay, this just means, right? And so you solve it using algebra. This is, we don't know how to do this. We don't know how to do this yet. Using graphs, we just kind of got an inkling. We just kind of saw how we did that, how we could do that in the last slide. And using T-charts, it means, just, make two charts and see where the numbers, make two charts and see where numbers are close or exactly the same. And we're going to do these two things in this homework help that I'm going to give you in a second. And now you kind of have an inkling how to do this. I'm going to give you the homework. I'd like you to struggle with it or try it or just crank through it. And then I'm going to show you how to do it. But these two things are things that you're going to need to know how to do on your homework. This equation thing is the thing we're going to get into very shortly in some upcoming lessons. Okay, so let's go to our example, and that's this. I plan to save, Mr. Lipscomb, I plan to save $20 per week at a constant rate. So get a load of this, at a constant rate. What does that mean about this $20 per week? What does that sound like? This is a rate. So a rate means a what? A slope. Starting with a savings of $30. So I'm starting with $30. This sounds kind of like a y-intercept to me. Y-intercept. Okay. My sister plans to save $25 a week, but has no savings. So she has a y-intercept, if you will, of 0. And she's $25 a week. I'll let you figure out what $25 per week is, given that I kind of gave you a little hint up here. Now, what I want you to do first is I want you to use two charts to figure out who will get to 250 first. So here's Mr. Lipscomb, and then I have Sis over here. Mr. Lipscomb, X, Y, and remember, X is almost always time. So time is going to be in weeks. And Y, our savings, is in dollars. This is Mr. L, Mr. Lipscomb. And Sis is going to have, we'll do Sis in not green, but we'll do her in pink. Okay, so I want you to figure out who's going to get to $250 first. If you want to go ahead and do B and C, I'd like you to write two equations that represent the savings and my sister's savings, knowing what you know about slopes and y-intercepts and knowing how to read these things, read these verbal models. And then C, I want you to graph them, okay? Okay, so I want you to pause and try. So this is what your whole homework is about. Pause and try. You're going to have some examples where you need to graph some simultaneous equations, and answer some questions. So I'm just going to label this. You should start working. Okay, I assume you're back now. And this is going to be in dollars. And this is going to be in weeks. Okay, so how does Mr. Lipscomb's savings go? Well, Mr. Lipscomb's savings go like this. We start with at week 0, we start with $30. That's also our y-intercept, which makes sense, 0, 30. So we're going to come right here and 0, 30. I'm just going to kind of put this point on the graph just to kind of get you started. After 1 week, we have $50 because I'm saving 20 every week. 2, 3, 4, 5. So let's go 70, 90, 110, 130, 150, 170. That's after 6, 7, 8, 9, 10, 190, 210, 230, 250. So after 11 weeks, I have 250. So let's just let's go ahead and graph that. Now we'll wait. We'll graph it at the end. Okay. Now my sister, let's see, she has after 0, she has 0. But after 1, 2, 3, 4, she has 25 because she's saving faster, right? Because her slope, for those of you who figured it out, that's her rate. Her slope is steeper because she is a better saver, or she works harder, or she has a better job. I don't know. 125, 150, 175, 200, 225, 250. So after 10 weeks, she has 250. So using the charting method, my sister has, after 10 weeks, she has 250, but I have, after 11 weeks, I have 250. So she saves faster, so she gets there quicker. So now let's write two equations that represent, because that's what the homework says. So let's see. So here, my slope is what? My slope is 25. And my y-intercept, where my x is 0, is 0. My b is 0. So my equation 5x plus 0, but I'm just going to write y equals 25x. Over here, I'm going to switch back to green. I get my y-intercept is 30, and my slope is 20. My slope is 20, my $20 per week, and my y-intercept is 30. So my equation here is y equals 20x plus 30. Now let's go ahead and graph me. Let's see. So I'm going to just pull a few points. Let's find some easy ones to graph. How about 6, 150? You know, 3, 90. And now let's go ahead and make my line. Oh, you know what I did wrong? I graphed this point wrong. Let's see here. 6 was, so 1. Six was 150. Let's see, did I get that right? All right. 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20. Okay, good. All right, so that's that. Now let's do my sister's savings rate of she's a star saver. So let's do my 0. Let's do 4 comma 100, 8 comma 200. Good. So we see that after 10 weeks, if we say, well, when do I get to, if we say, when does each of us get to, 300 to 250? You say, well, there's our 250 mark. And we can see that I get there, or my sister gets there in 10 weeks, but I get there in, 11 weeks. Which is cool. So we've graphed both of them. Now another question. So we've done our, we've written our 2 equations. We've charted and we found out my sister will have more. We'll get to 250 faster. We've written our 2 equations right over here. We've graphed the 2 things and we've proven that my sister will get there faster because she'll get to 250 here in 10 weeks and I won't get there until 11 weeks. But the other neat thing you can ask about this graph is, when do we have the same amount? This is what I call D. When do we have the same amount? And we can answer that question at least in 2 ways. We can do it by looking at the graph and see that it crosses right here. So we have the same amount of money at 6 weeks. This is pretty cool. 6 comma 150. So the answer is 6 weeks. And what's totally cool is that we can look back at our chart and see which week is it that we did have the same amount. And it's only here. At week 6, I had 150, and at week 6, my sister had 150. That deserves a happy cat. And that's going to be true. It's going to be really neat. And what can you expect to learn about when we learn to solve these equations algebraically? We can solve them. We can find the solution, the point where they cross, graphically right here at 6, 150, or we can do it via the T-chart method right here. But we also can solve it algebraically, and we're going to learn how to do those in the upcoming lessons. But one thing that you can expect is that when you find out how to do this algebraically, that your answer is also going to be 6 comma 150. And with that, I will leave you, and we will come back to me. Introduction to Simultaneous Equations. Remember, this was just an introduction. A lot was thrown at you, but we're going to spend 7 lessons coming back over and over and over again to this same concept of simultaneous equations, that algebraic equations, graphs, T-charts, verbal models, all the same thing, bringing back in the concepts we learned earlier this lesson about slope, about linear equations, about y-intercepts, about how to write equations given various pieces of information, and how to move back and forth between graphs and linear equations and t-charts. And that is the essence of 8th grade math. If you are getting this, if you're getting most of this, you're doing awesome. This is what the building blocks that you really, really need. All right, we will congratulate you for staying with me, and we will move forward with lesson 25 next time. Take care.